Good evening. Today we're working on electricity. The first thing that we need to know is the electric current. Electric current, which is by definition you can calculate by charge over the change in time, where I is the current that is measured in amperes, Q is the charge in coulombs, and this is the time in seconds. And then going to the next one, potential difference. V is equal to the charge over the energy, where V is the voltage in volts, Q doesn't change, is the charge in coulombs, and this is the energy in joules. Now we need to also study the instrument that measure current, which is called the ammeter. What does the ammeter do? It measures current. It is always connected in series. Why? Because it is a very low resistance, and the unit it's amperes, which is the caps A. Okay, again we need to also study the voltmeter. It measures voltage, whether EMF or potential difference. It is connected parallel, and again it is high resistance, and the units are volts in V. Looking at electricity, we need to understand what is Ohm's law. By definition, it is the potential. Remember to always take the definition from the examination guideline. It is the potential difference across the ends of a conductor is directly proportional to the current in the conductor whenever the temperature is constant. Now let us look at the relationship of Ohm's law. R is equals to V over I. We can see that resistance is directly proportional to the voltage in the conductor, and resistance is inversely proportional to the current that is in the conductor. Okay, you also need to understand what is EMF. Electromotive force. This is the total amount of energy that is supplied per coulomb of charge in a cell. EMF is equal to the I over the external and the internal resistance, which you can simply say it's I R plus I R, which will make the V external and the V internal. Now, when I look at the circuits, two types. The first one, the series circuit. What do we know about the series circuit? Is that the current is the same voltage is shared, and to calculate the total resistance, it's R1, R2, R3, depending on how many number of resistors we consume. And again, we have the parallel circuit where current is shared and voltage Let's just say, and to calculate that, it's 1 over R1, 1 over R2, 1 over R3, depending on how many circuits do we have.